guys, here's the Pro 600 CDI box from MSD. Today I'm going to go over the wiring and installation of it, as well as its functions as it pertains to how it integrates with Holley. So the box itself comes with this harness here and this harness here. All right, and it comes with instructions, and then your coils. Each coil, part number A232. Comes with a little connector kit, some spacers, and nuts and bolts. So I've already swapped out the coils on my personal car from the smart coils to these CDI coils, and it's a pretty basic swap out. It consists of the same bolt pattern as the smart coils, so that's kind of a bolt in and go type of deal. This box, what this does is it puts out substantially hotter spark than what your smart coils are capable of, right? So this unit's actually recommended for people making more than 5 horsepower per cubic inch on with a smart coil, and if you're having issues. The reason I'm switching over to this is because I'll be able to richen the tune-up up and lean on it a little harder and get a little bit more power out of it, where the smart coils were starting to show some signs of not being able to keep up. So a couple of things I want to point out with this. There's a couple other CDI boxes out on the market. M&W, I believe, is the first company out there that does them, and then Fuel Tech came out with the FT Spark. Just for reference, this uses 10 less amps of draw on your electrical system inside of your car than all the other competitors. So it's a more efficient unit. This is also designed for continuous duty, even at full tilt, like full power output to the coils. So the competitors, you cannot run these, or you can't run their unit at continuous duty street car stuff. My car is a street car, so this was a no-brainer for me. But competitors you can't use on the street, and this you can. And then you've also got, this actually puts out 20% more energy at the plug. So at the actual spark plug, there's actually 20% more energy than what else is out there on the market. And double the length of spark. So I believe this sparks up to 300 milliseconds, where others do not. You can go and dig around if you want for competitor stuff, but that's what this does. So anyway, I'm going to go over how to put this thing in the car, how to make it work, and how to program it. The first thing I want to point out is this is not light, okay? This probably weighs about 6.5 pounds. It does have a heat sink on the back of it, so after continuous use it does get a little warm, but they send off standoffs, so basically just either bolt it to something aluminum that'll help dissipate the heat, or use a standoff so it can get air behind it. One car's already ran this thing on drag week this past year without a hitch, so it holds up to continuous duty, but you have to kind of plan ahead. So what we're going to do with my own car is actually my girlfriend made a piece of carbon fiber. She cut it out to bolt into the car, and we're going to use the standoffs to space this off the backside of the carbon fiber, so there's some air that can get behind it and help dissipate some of the heat. So as far as mounting, use some common sense. Put it onto something aluminum or use their standoffs, but use some common sense. Don't put it next to a turbo header or something like that, because it's going to get too hot. The next thing about this box itself is there's some indicator LEDs here, and in the manual it goes over what each indicator means, but it's basically cylinders 1 through 8, A through H, and then a power indicator. This will show you faults in the Holley software. It'll also show you misfire data in the Holley software over CAN bus, which is a huge selling feature to me. That's pretty important. So let me go into the actual wiring of it. So it comes with this harness here, okay? So this harness here, I've got it zip tied up and taped up right now. But the first thing that I'm going to touch on is this. So you've probably heard me harp before, but run these directly to the battery, okay? This needs to be able to supply at least 50 amps. So run these directly to the battery, or if you've got a power post somewhere that's fed directly from the battery that can handle this kind of amp capacity, these go to there, okay? Good ground's always important, and don't just, use a sheet metal screw into your dash or something, for a ground. It's got to be a good ground straight to the battery. Next, you've got 8 twisted pairs. So they're twisted for a reason. It's to help reduce noise. So keep them twisted. If you're going to make your own harness, twist your own harness, but make sure that the wire is actually twisted over top of each other per cylinder, okay? So the brown wire for each cylinder goes to the brown here. It's all outlined in the manual, and gray to here, and then all 4 of these per bank, okay, this lead here, all 4 of these per bank is going to get grounded to the cylinder head that it is firing on. So just like your smart coils, I've already made a harness myself for each one of them, or each bank, and they are grounded back to the cylinder head. They all join together, 16 gauge here, and then they join together to a 10 gauge that goes to the back of the cylinder head. We'll look at that in a minute. So make sure that this doesn't get grounded to the sheet metal or to the frame or something like this. This gets grounded to the cylinder head that it's firing on, just like your smart coils. And then here's your 2 wires coming from the box. So coil, for an EFI application, let's take a look here. For an EFI application, right, here's an LS. Notice this is extremely important. Output A is cylinder 1, output B is cylinder 2, output C cylinder 3, so on and so forth. So, here's a picture of an LS, 1357. So cylinder A, cylinder C, so on and so forth. That's going to go to this side, this is going to go to this side. I'm working on a small block Ford because it's a superior engine, obviously. So, why would we, handicap ourselves with an LS? We're working with a small block Ford. So what I'm going to do is take cylinders 1 through 4, which are here in this bundle, and they're going to go to the passenger side. And then cylinders 5 through 8 are going to go to the driver's side. And it will be fired from the Holley, being told what cylinder is what in the firing order. So just follow output A to cylinder 1, output B to cylinder 2, not in the not in the sequence of your firing order. Okay. Now, if this is going on a power grid or a profiler, it works a little different. You follow the firing order, so they give you a little spot where to put the firing order, and which pair is going to where. So it'll show you, look, output pair B is going to go to, whatever is next in your firing order. But that's not what we're doing. I'm not working with a grid. I'm not working with a profiler. We're working with the best EFI system on the planet, and we're going to follow these instructions here. So that kind of covers how you wire this up. Once I have this all installed in the car, I'll go over, kind of setup and everything on the output side of it. Now on the input side, they've made it really simple. If you're going to make your own harness, it's fine. But if you do have an LS, if you've made that mistake before, this right here will plug in, and then this right here, these probably look familiar. Passenger side, driver side. So these plug directly into your existing Holley main harness, and send signal in the corresponding order that they're supposed to be sent to this unit. So this unit is basically interrupting what you have now going out to your smart coils, or to your LS coils, or what other coil you're using. So here's all the trigger wires from the ECU, right? So it's going to come from the ECU in here, and it's going to go from here down into the CDI box, and then it's going to output through the CDI box to the coils. So if you wanted to make your own, this, which is what I'm going to be doing, what you'll have to do is literally just cut these ends off right here, and you run them to, whatever connector you've got going on for your coil harnesses. So, and again, it follows the same sequence, right? So Ford has got a different pattern than Chevrolet, so they're all labeled input A, input B, input C. So pay attention to the print that's on the actual wire, and should be pretty painless. The next thing, this loose green wire. So this, when you ground this wire, if you're not using Holley, if you ground this wire, it puts it into 600 milliamp, or I'm sorry, it puts it to like maximum output, right? So this, with this wire here, when you would ground it to basically go to 600 millijoules of output, as opposed to the standard of 380. So this basically, like, consider this your race mode wire. We're not using this because we're on Holley Efi, and we can control it via CAN bus. So here's your CAN bus connector. You've seen these before. This can plug directly into the Holley CAN bus. It can work with anything else that's on the CAN bus as long as the CAN bus channel is designated for Holley. If you've got a race pack device on the same CAN bus channel, it will not work through CAN bus. If it does not, if you've got like an EGT box or a dash or something from Holley, you just plug it right in, and all the data will go across the CAN bus, as well as what I think is one of the biggest selling features of this unit, which is the misfire data. So I'll show how to set up those inputs in the software once I have all this stuff installed. So CAN bus if you're in Holley, this green wire if you're using like a power grid or a profiler or something like that. If you've got like a mechanical injection setup with a profiler, you can trigger this wire, you send a ground to it, and it'll put it into full output capacity. So which is 600 millijoules, 680 millijoules. I'm sorry. This wire will only go to 600 millijoules. In the software, you can overdrive it to 680 millijoules output through Holley. So if you're running a profiler or a power grid, hook this up to an output, send ground when you want it to be wide open, you're good to go. If you're using Holley, use a CAN bus. Plug it right in, and then we set up a table just similar to our dwell table, and we're good to go. So as far as mounting of the coils, they give you some standoffs and whatnot. I'm going to show you what I did over here on the car. So I had some Maven mounts that were for smart coils, and they literally just swapped right out. I've already made my own, harness that goes from here to the firewall, and then I didn't even have to remake spark plug wires or anything. But however you're going to mount them, it's fine. Just make sure it's sturdy, strong. It's not going to fly off of there. And then what I did here was I joined all the wires together to a 10 gauge. This is a Tevzel wire, but I joined it all to 10 gauge, and it's going to go back here to the back of the cylinder head. So just like your smart coils, they all have to be grounded to the same cylinder head that they're firing. So I'm going to make my girlfriend crawl up inside of the car and wire some stuff up for me, since I can't get in there, and I'll be back here shortly to show you kind of the rest of the installation and then programming of this thing. See ya. 3 things I forgot to go over here. The first one, and probably the most important, is this pink wire that is in the driver's side connector for the plug and play EFI application needs switch 12 volt to turn the unit on. So if you were to plug this into an existing Holley harness, you should have 12 volt, switch 12 volt on this wire anyway to power up coils. So that if you do end up making a custom harness, this pink wire right here needs switch 12 volt. It's in the manual as well, but it's something I forgot to go over when I was talking about the plug and play side of things. The other thing that I actually forgot to get into was the power grid or profiler setup. So this is the CAN bus plug for your power grid, and you plug right into your profiler or power grid with this. It comes with the unit, no matter however you order it. Doesn't matter if you order just the part number without the coils or you order the part number with the coils, and then this goes into your cam sync. This is the complete deal no matter what your application is. So you'll have quite a few harnesses, and some of them you won't be using. So like this whole unit right here in my application won't be used. So, because we're going to be going through the EFI with it. So you have to have 12 volt on this wire, pink wire in this loom. And this is for your power grid applications. And then they give you a schematic right here in the manual for power grid and for profiler and how to connect it and whatnot. So I don't have a power grid here or a complete profiler. I have a profiler EFI module, but for the complete profiler units, like if you were running mechanical injection or something, this would be how you set it up. So I've got this all in the car. I had it fired up last night. Anyway, kind of hard to see, but there it is. It's mounted. It's all in there. Harness is made for the coil side right here. That's all done. Spark on this is very hot. I'm going to go over the software here in a second and set up, and I'm going to show you a couple logs of the miscounters and the spark duration and whatnot that comes across the CAN bus channel from Holley. One last thing I want to point out is when you hook up the CAN to the EFI, you have to make sure that one, your terminating resistor across the CAN bus is plugged in, and two, you have to make sure that it's I found that it worked best by putting this the last in line on the CAN bus. So the way my CAN bus is wired in my car is it comes, see right there, Holley Efi connected CAN bus if applicable. The way it's wired in my car is I have it comes out of CAN channel number 2 from the ECU, plugs into here, and then jumps from here into the EGT module, and then from the EGT module into the dash, and then at the dash connector is where I put the terminating resistor. It's got to be the last in line. So we'll go over the CAN bus terminating resistor has to be the last in line. So we'll go over some setup in the software, and I'll show you some data logs of all the miscounters and whatnot. Be right back. Got the MSD box all wired in, and as I was showing you before, the part number is on the box, but I figured I would just show you on the website. Just for the CDI box itself, this is the part number 8000, and then if you want to buy the kit, it's 8000-8. I expect these shipping dates to actually be a little bit sooner. I believe it was just a boxing holdup, but anyway, so what we're working with here is the 8000-8, and comes with 8 coils, like I showed you, box, the harnesses, the whole 9 yards. And it's got a whole bunch of information that we already covered in this video. You have to be on EFI V5 build 130. Okay, so I made a video on how to update the build 130. It's just like updating any other software through Holley. So there's the website for each individual one. Now let's look at the software side of it. So here we are in the Holley software, and what we're going to do, this car originally was on smart coils, and I swapped it over to these CDI coils. So we go to ignition parameters, go to ignition type, you're going to go to custom and then configure. This stuff is all going to be based off of your cam and crank info, so none of that changes. But we're going to change the output setup type to the MSD Pro 600-8. Okay, and we're going to enable ignition power table. So you've probably been in here before for dwell. Now we're going to do power. So we're going to edit the table, and I've got it on 30% at idle, and then it slowly ramps up to 100% power once we get up into boost. So you can do this however you want. You can change your scaling like this. So, maximum RPM is going to be 9,000 on my engine, and then maximum boost you can. Still, like I think maximum boost on my fuel SEF is, or my fuel table is like, 43. Scale it however you want. And what you're doing is you're basically turning up power. So you can kind of look at this as dwell, the same type of thought process as it behind dwell from your smart coils, but this is actually ignition power. So 30% it'll recognize 23%, so I believe like 110% or 105% power, but I just left it at 30 here. The standard table's 30 and rolled it to 100% by 4.5 psi. So that's ignition power. Now we're going to look at the setup of the inputs and outputs on it. So we go inputs and outputs, and so there's a lot of different inputs and outputs that you can add. But what you'll do is you'll enable a whole bunch of these. Okay. So MSD internal temp, converter voltage, ignition energy, and then spark period and miss counter are what I'm monitoring. You can also monitor efficiency of each coil. I ran out of space because I have too much stuff. So I've got way too many inputs and I ran out of space. So this is what I'm working with. But it gives you a rundown on how, I'm going to give you a rundown on how to do it. So the first one, fault mask. It's in the instructions. It's basically bit coded to different numbers mean different things, right? So if you only wanted to monitor one thing, you could just monitor fault mask, and it'll tell you all about all of this stuff by the bit. I'm going to show you how to do each and every one of them. So fault mask, it's a CAN type input. So it's not defined, it's not in your pin map. Enable and then go to configure. What you'll do is the setting, the type is raw, okay, and then you'll choose the CAN device. So it's the MSD Pro 600-8. And then what you'll do is you'll choose your CAN channel, right? So right here it says fault mask. This is what we want to monitor. Let's come over here, click fault mask. And I am on CAN bus 2, but you'll probably be on CAN bus 1. And the CAN serial number for all of them, every single one of these inputs is 1, okay? So you don't have to worry about trying to pick up, the back of the box or trying to find the CAN serial number anymore like you do with EGTs. So the CAN serial number is 1, okay? So that's fault mask. And then let's go to the miss counter. So like I was explaining before, this is basically going to show you if you've got a miss in a cylinder. So this and spark duration are pretty important in my opinion. But again, MSD Pro 600-8, CAN channel is going to be miss counter coil 1. And you can see it's coil 1 through 8, spark period 1 through 8, efficiency 1 through 8. So this one's cylinder number 1, miss counter coil number 1, CAN bus channel is number 2 for me, but it'll probably be on 1 or 2 for you. And then CAN serial is 1. Two things I want to point out is when you do this, if you've got race pack or something, or if you've never used any CAN bus information across your Holley before, you need to go to EFI, basic I/O, and go to CAN bus, and make sure both CAN bus types are Holley standard. So I know it's an MSD product, but it's talking across the Holley standard CAN bus. So make sure that they're both Holley standard. If you have a Dominator, if you have a HP, it'll only be the CAN bus type 1. So, okay, back to inputs, and you just keep going, So here's spark period, configure. Again, spark period coil number 1, CAN bus. I'm on CAN bus channel 2, and the serial number is 1. And then we can go and look at ignition energy. Once you pick the CAN channel and the CAN device, all this will populate itself. So this is in millijoules of energy. So once you have all these done, you sync it with the ECU and you start the car up. You can data log and look at what you got going on. So let's look at the data log. So here's the data log. This is, I've only set up a couple things here, right? So this is the first thing that we'll look at is, here's RPM. This is me doing another video I'm doing for trans brake testing, which I hopefully have done later today. This is RPM, okay? Now if we look, fault mask is 0, okay, because it never sees any faults. There's never a miss or anything like that. So we'll disregard that. Let's go to ignition energy. So you can see as ignition energy, as it rolls up, right? So as you're increasing RPM, we're going across our power table, in essence, and we are getting closer to 100%, which is, which would be 600 millijoules. And now we can also monitor converter voltage, right? So the converter voltage is, again, if you notice, these numbers are quite a bit higher than what you're thinking. It's not 12 volt anymore. It's not DC. We're sending AC power. So 458 volts. And then you also have internal temperature. So there it is. Internal temperature, this was from last night. It was 74 degrees. So there's a 73 degree for a split second, but it was 74 degrees. And this is something else that will show up in a fault if you had an over temp situation. Now we can look at spark period and miscounter. So here's all the miscounters, 1 through 8. They're on the bottom panel here. And there's no misses during this entire spool up, right? But now we can see the spark period. So the miss happens when your spark period goes over 200. But our spark period during this spool up test was pretty uniform around, I think our high point here was, let's look, the minimum is 85 and the maximum is 92. It averages 89. So it's right in line with where it's supposed to be. If you can use this to start seeing if you've got a problem on its way, so if you make a run and the spark period averages like this here, it averaged 89. If you see spark period start to climb to say 150, 175, or if it's completely out of your norm, you've got an issue that's about to get a lot worse. So it can, point you in the direction of like maybe looking at spark plug wires, maybe the plugs are bad, some ground, some loose ground, something like that. So again, this was like the big selling feature for me, was to have this data. As some of y'all probably already know, I'm a little bit of a data junkie, and this stuff to me is extremely important. So being able to see spark period is pretty cool. I don't know of anybody else who's really doing this and doing it accurately, but yeah, that's really all there is to it. Obviously, this looks crazy, but if you look at them one at a time, it's not bad at all. So, or even 2 at a time, right there. So, and obviously they shouldn't overlap over top of each other, because one cylinder is supposed to fire at a different cylinder, then a different time as a different cylinder. So anyway, that's the CDI box. So far, I am very, very impressed with this thing. Spark is hot. I'll show it in my spool up video, but the amount of fuel that you can add on an alcohol combo and still light it off efficiently is rather impressive. At least for me it was. So over the smart coils at a 7 millisecond dwell on a 16 volt system. So I'm pretty amped about this stuff, and if it fits your application, I definitely recommend it. If it doesn't fit your application, you'll probably be fine with smart coils. This isn't for everybody, like I've said before, but it is definitely for the people that are in the know and the people that are looking for every last bit of power, and you're dealing with alcohol. This thing's pretty awesome. So hopefully that helped. Have a good one, guys.